In this video, we're going to look at graphing the solutions to equations that have two variables. And since they have two variables, they will be infinite solutions to this equation. So if you look here at this equation, this is 4x plus 3y equals 12. It has an x and a y in it, and both of these variables have an exponent of 1, so this is actually a first-degree equation because the highest exponent is 1. It has two variables, so it has infinite solutions, and a first-degree equation with two variables is called a linear equation because those solutions to this equation will form a line. And so your answers will look something like this first graph up here. But I want to talk about this graph because anytime you have a line, a slanted line on a coordinate system where you have your x-axis here and you have your y-axis here. So these are your x values and these are your y values. A slanted line or a line of solutions will cross the x-axis at a point, and it will also cross the y-axis at a point. The point where it crosses the x-axis is called the x-intercept. We abbreviate that x-int. And the point where the line crosses the y-axis, we call the y-intercept. So in this example, the point where this picture crosses the x-axis is at -2 on the x-axis and at 0 on the y-axis. And you might realize that anytime the line, anywhere it crosses on the x-axis, wherever it crosses, the y value of that point would be 0. And then likewise, when you look at the y-intercept of this example here crosses the y-axis at 1. So when we write that as an ordered pair, it's at 0, 1. And then again, you might realize, and I'll put them over here, 0, 1, and -2, 0. Wherever this line, if this line had crossed the y-axis any other place, wherever it crossed the y-axis, the x value of that point would be 0. So intercepts are points that have zeros in them. For the x-intercept, we have 0 for y, and for the y-intercept, we have 0 for x. Now we're going to use that information to draw these lines. So if we don't have the graph, but instead we have the equation, like example 1, we can use the information we learned from intercepts to find the intercepts to this equation. So we know that the x-intercept of this equation is when y equals 0. So what we can do is let y equal 0 in this equation. So we could say 4x plus 3, but instead of a y, we'd put parentheses 0 equals 12. And then 3 times 0 is 0, so we would just have 4x plus 0, or 4x equals 12. And from that equation, we can figure out what x equals by dividing both sides by 4, and we find out that when y is 0, x is 3. So we found an x, that means we found the x-intercept, and we found that by letting y equal 0. So the x-intercept of this line is going to cross the x-axis at 3 on the x-axis when y equals 0. And now let's find the y-intercept. So the y-intercept, remember, we said that anytime a line crosses the y-axis, it will be when the x value is 0. So to find the y-intercept, we're going to go back to our equation, but instead of an x, we're going to put a 0 in for x and keep the y. So we're trying to find the y value by letting x equal 0. Well, 4 times 0 is 0, and 0 plus 3y is 3y. So we end up with an equation that we can solve for y. To solve this, we would divide both sides by 3. And now we find that y equals 4 when x is 0. So in other words, we're going to have a 0 for x and a 4 for y. So going to our graph over here, we'd go to 1, 2, 3, 4 for y. And now these are the 2 points on our line. If we connect these 2 points, what we have just found is the solution, all the infinite solutions to our equation. And so if we were to pick any point on this line and plug in that x and that y, we would find the solution to this equation. So let's do one more example. So if you look at example 2, our equation is 2x plus 3y equals 12. So again, it has 2 variables, an x and a y, so this is going to be a slanted line that goes through the x-axis and through the y-axis. And this time we're going to find where it crosses the x and y-axis by finding our intercepts. So let's say we want to find the x-intercept first. Then we're looking for an x, so we're going to let y equal 0. So what we would have is 2 times x, because we're trying to keep the x, plus 3 times 0 for y equals 12. 3 times 0 is 0, so we'll have 2x plus 0, or just 2x equals 12. Again, we can find our x value now by dividing by 2, and we get x equals 6. We found an x when y is 0. So if you find an x, you have found the x-intercept. Oops, that is 0, 6. So we found the x-intercept when x equals 6, y is 0. If you find an x, your dot goes on the x-axis, 1, 2, 3, 4, 5, 6. And then for the y-intercept now, we're going to let x equal 0. So we'll find the y-intercept by letting x equal 0. So we would have 2 times 0 plus 3 times y equals 12. And that would give us just 3y equals 12, because 2 times 0 is 0. Divide both sides by 3, and you get y equals 4. So now we know that we will have a dot on the y-axis at 1, 2, 3, 4. And then written in ordered pair form, the x is 0 when y is 4. Connect these 2 dots. And what we have drawn is all the solutions to this linear equation.